Welcome to this webinar, Geospatial and its impact on construction. I am Thomas Lane, the technical editor of Building Magazine. In 2020, the government's Geospatial Commission launched the UK's Geospatial Strategy 2020 to 2025, setting out the role it believes location data can play in addressing industry concerns such as improving infrastructure, tackling climate change and building new homes. Analysis from this strategy suggests that more accessible and better quality location data in infrastructure and construction could be worth over £4 billion a year. But how do we get there? How do we achieve these benefits? So to discuss this, I am joined by four experts. Maria Mamora, Director in Creative Technologies from Bryden Wood. Elspeth McIntyre, Senior Geospatial Consultant at Atkins. Callum Agnew, a Director of Sobin. And Christina Rui Nolasco, Senior Digital Construction Manager at Sir Robert McAlpine. So the format of today's session will be each panelist will speak for about 8 minutes. Everyone has a sort of presentation. And then once these formal presentations are over, we can take questions from you, the audience. So I would encourage you to put forward any questions that you want to know answers to anything to do with geospatial and its impact on construction. So in terms of what people will cover, Maria will outline how geospatial data is being used to automate design processes with a range of government agencies, including Highways England, Network Rail and Transport for London. Elspeth will explain how geospatial data is being used in the context of environmental risk assessments, with the idea that this will actually help reduce those risks. Callum will talk about intelligent project controls and how a common data environment allows for easy comparisons of projects across a region on one platform. And Christina will discuss the benefits of point cloud surveys and the benefits that those bring to projects. So without further ado, I'd like to hand over to our first speaker, that is Maria Mamora from Bryden Wood. So over to you, Maria.
Thank you, Thomas, for the introduction. So my name is Maria Mamora and I'm Director in Creative Technologies team. And on my day-to-day work, I lead the algorithmic work and automation across different projects in our team. So today I'm here to talk about how we use geolocated data to inform our design through a set of infrastructure projects. Rapid engineering model, a project we developed with National Highways, RAID, a project we developed with Network Rail, ARC, a project we developed with Transport for London, and SPACE, which is a platform to create cycling routes. That was a research project in collaboration with some cities across the UK. So there is so much effort to connect the physical environment with the digital information. And why is this that important, and how we can benefit from this connection in our design phase and eventually the construction phase and operation of what we build. So until now, we have managed to develop very detailed 3D models that could represent our designs, and we can have a really good idea of how they could look at the built environment. But let's go beyond that and let's have a look on how we can take advantage from using data, and especially like geolocated data, and how we can interpret those data sets in different ways so we can identify challenges and opportunities across the different stages from design down to construction. So through the projects that I'm gonna take you through briefly, it's like I want to show you how we can interact in both those two versions, like how we can work with the data and how we can see how our design looks from getting information from these data sets. In rapid engineering model, our role in Brighton Wood was to develop an automated workflow that places the equipment we need on a road network across the network of the country. So our role in that was to collect rich data sets, and this is information that comes from so many disciplines that are involved in the design of roads. And we had to overlay those in order to be able to assess the design process and help the decision-making process much more in advance, where like from concept design. What is important here is that here we can show how this data set look in a graph through different 3D graphs, and we can have information about the geometry of the road, such as the curvature or the visibility conditions. But beyond that, we know about the topography around the context, in the context that we have to analyze. We know about where we have residential areas or waterfront lines, or even where the badgers live, which is very important information when we are about to construct something across the roads. I want to mention like here an example that the fact that we could use geospatial data about environmental assets that affect the design of roads, it was a crucial information that we had available much in advance and at early stages of the design process, as that could inform other disciplines early in the design process. Usually, the construction phase was disrupted by not having this information available at the right time. Now, let me take you in London Underground, where we had to we had to create a workflow that automates the route for new cabling system. In that case, the input we had was a rich point cloud, and more or less we followed in principle the same process as we did in roads, where we had to work with the different rules. We had to understand the conditions in London Underground, and we could create many design options in order to explore what is the best route for the new cable system. What I want to raise though in this project is the fact that we didn't have available as a separate geospatial data set the existing equipment, and we spent so much time and effort to separate this information from the existing tunnel surface. So from this project, I want to raise the fact that if we had the equipment that we have already in our built environment available as a separate geospatial data set, that could speed up the process and that could give us much better information in our design process. In RAID project, a project we developed with Network Rail, that was focused on a separate state that was only concept design. And the aim here was to create a platform which helps us design the rail, a new rail path, again, like at very early stages of the design. Here, though, what was important was to understand the area of our interest and analyze that before we actually designed something. So we collected different sets of different geospatial data sets. Again, that could include buildings, surface water lines, the road network, railway stations, eventually anything that we need to know in advance before designing a new railway path. So by applying different weights on these data sets, we can control like what is more important than other data sets, and eventually create the new digital testbed where we can actually design our, we can explore our design options. Eventually, this comes as in one common platform. So when we define the start and end point of this railway path, we can explore which are the design options that we can create, and we have at the background all the information that we collected in advance and the risks that we can potentially need to face in our design process. Similar logic we explored also in space, and that was a research project where, again, it has a similar logic with RAID, that we need to collect, first of all the information and all the data we have available that could describe a city that could describe a specific neighborhood, an area of our interest, no matter what we want to do, and actually before even deciding what we want to design. So by having this information available, it allowed us to analyze those and evaluate the conditions that we had in specific areas by following specific rules that we should take into consideration for creating a network for new cycling routes. So again, the advantage we have is that much in advance and at early stages of the design process, we can easily identify and capture the challenges and opportunities we have for our design solutions. Eventually, we can apply different methodologies, whether this is automated or manual, but even through automated processes, what we can achieve is that we can easily connect, we can actually design our network and get direct information from the data set as a feedback on whether what we design is feasible. And again, most important is to know which are the challenges that we will need to face. And eventually, as soon as we have everything, all the data set with the location attached on those, we can achieve really good simulations by overlaying our future designs in our cities or the environment or the area we are exploring. And the more accurate the information is, the better design decisions we can make in the design process. I would like to close this session with the list of open data sets we use, geospatial open data sets we use across the projects. And I wanted to raise the importance of how helpful was that in our design process and our exploration, because it allowed us develop our methodology and explore the conditions at early stages. There are always questions on whether these data sets are accurate enough, and definitely there is room for improving here. And but by having this information available, eventually what we can achieve is that we can target our focus in specific areas that we believe we might need to make more detailed surveys. Looking forward for our discussion later on. Thank you very much.
Great, thanks very much, Maria. Just quickly before we move on to our next speaker, I mean, how much time or sort of money does using this technology, you know, what are the savings, you know, in terms of time and money when you're using these technologies on these projects?
I'm not the right person to talk about the money that we save, but I can use like a REM since it is a project to explain like the feedback and transfer to you the feedback that we had from people who are working in highways for so many years. So we work in REM since 2017, and this is an ongoing project. And actually the fact that we have this information available, there was a great feedback because we could work on issues that usually disrupt the construction at early stages of the design. That was the main advantage that we achieved through the use of geospatial data in our design process. So the good thing is that since we automated like the workflow, it means that as soon as we have something more detailed and something more accurate as a data set, we can update our process and we can get directly feedback on the decisions that we have made. So yes, we save lots of time because we, in just months, we can explore the constraints that we will face and the challenge that we will face even later at the construction phase. And again, like the example of the badgers, which is kind of, well, a funny example from my side, but actually it is a very important information to have during construction phase because it has disrupted so many times the construction. It has postponed the construction and not only badgers, but even like different environmental assets because this information wasn't available at early stages.
Right, you know, that's really interesting, Maria, and actually I think there are neatly dovetails on our next speaker. So thanks very much to Maria. And our next speaker, Elspeth McIntyre, is Senior Geospatial Consultant at Atkins, and she's actually going to be talking about how geospatial data can actually reduce the risks when doing environmental risk assessments. So over to you, Elspeth.
Thanks very much. Yes, so I'll be talking about geospatial for construction, and it does indeed dovetail nicely because I will be mentioning our favourite construction animal, the badger. Of course, when you're looking at the construction phase, then everything that's come before it, all of your detailed design, all of the strategic master planning, right at the very conception of your scheme, has been done via data and often via geospatial data. So you've got this absolutely cracking legacy from those stages where you've got a huge amount of data, a huge amount of data-driven decisions, and all of that's being communicated to a construction site where things are moving very quickly, various different environmental impacts, various different program and scheduling changes will occur, and all of the data that was collected at design stages needs to be fed into those decisions as well. And the new data that's generated needs to be fed back into this resource, this memory of the project in order to come out with the best possible result for your project and for the environment in which that's set, whether that's end users, whether it's stakeholders who live nearby, whether it's natural stakeholders or the general kind of economic and spatial plan for that area. So we believe, of course, as a geospatial team, we do indeed believe that geospatial data is really beneficial for construction. We believe that it makes things faster, it makes things safer, it gives you better results, and you get that through your spatial data and through your spatial analytics. So what does it mean to be a geospatial professional, and how does that relate into construction? Because we're very used to using it at design phase when you're using lots of new and innovative technologies like automated design and like common data environments, but how does that transfer over? Well, within our team, we've got over 90 professionals and they come into geospatial from different angles. So it's not that it's a single discipline, and it's not a single discipline that can contribute to a construction site all in the same way. We've got experts in data capture and data management, and I'll be talking quite a bit about the data capture angle today. But we've also got ground survey, we've got 3D visualization, internet mapping and web portals, which of course are so crucial in getting the data from one place to another. And then spatial analysis and modeling, because that still needs to happen at construction phase. It's not just consigned to the design phase. And you've got lots of other kind of sister disciplines, such as drone piloting for additional data capture of LiDAR data, for example. Within that field, GIS specialists don't just talk to each other. That's something we believe is really, really important for success at any stage of a project, but particularly construction, where things move so fast and communication between different disciplines is so important. So we focus on this industry-wide collaboration. We're members of the ISO BIM GIS working group, the ICE Geospatial Engineering Panel, and its new sister organisation, the Data and Digital Working Groups, which they've set up. Also within the IEMA Digital Delivery Special Interest Group, and that's a really important one, because often geospatial is the uniting factor between civil engineers who are looking at design, they're looking at design issues on site such as stability, resilience, flood management, and they need to interface with professionals on site who are there very much from an environmental point of view. So how will this design impact? Can it impact positively? Are there net gains that we can achieve? So understanding that civil and environmental side of things and bringing those together as they operate in the same place via locational data is incredibly important, incredibly beneficial to the overall picture of construction. And that brings us to 3 geospatial constants, which we believe are of highest importance when you're looking at a construction phase and you're looking at where geospatial can contribute. Firstly, you need to have good data. Much of that data should come before construction phase has started, so coming from your detailed design team. It'll be environmental, there'll be designs, there'll be mitigation designs, and there'll be lots of contextual information. To understand the decisions that the design team have made, you need to understand the data they were dealing with. So it's got to be clear when that data was available, at what time a decision has been made, what information was available to that decision maker. And you've got to understand the the limitations of that data as well. For example, if there is a utility plan that's been issued in a GIS database, then do you know that that utility plan was done on a kind of national basis when you might expect granularity issues at a local scale? Or is it perhaps only certain types of utilities? So it's got a lot of the 11, but none of the 400. It's not that it doesn't exist, it's just not within that data set. So having that good data and the good metadata is absolutely crucial at construction stage, and Geospatial offers a lot of ways to supply that data in an understandable way, and that's via good systems. So there's several limiting factors for a construction site when it comes to systems. They might have a low level of technology availability on site. You're not going to have a super high spec analysis laptop sitting about that's going to be available for everyone to use. You might also have internet issues if you're in a remote area. So ensuring that your data delivery system, particularly for spatial data, is absolutely specialized to your construction site and tailored to make sure that it can achieve its aims there is absolutely crucial. Thirdly, good communication. Within the design phase, it can sometimes feel as though you're always speaking to people who are digital natives or digitally fluent. You've got CAD and GIS working very closely together, lots of technician availability between different teams, lots of analytical specialists. They're really familiar with the data, they've probably worked on it for a number of years or at least a number of months, and they understand a lot of the history of the data. When you hand that over, you need to present it in a way that's going to work for everybody who's going to be on that construction site. They're not going to take data the wrong way, they're not going to be misinformed, they're going to understand how everything fits together. And that could involve stakeholders as well. You might be keeping public stakeholders informed of progress through construction, and often that's an amazing attribute that Geospatial can offer, because people will look at a map, see their house, see the proximity to the construction site or to any other issues, and they will understand that frequently more often than they would if they were given a written answer or an answer that's in charts and numbers. It's very intuitive. People are used to using mapped systems now, such as Google Earth and Google Maps. They like it as a picture. It's that picture tells 1,000 words type principle. So the challenges that GIS answers on a construction site. You've got unification. So you've got these diverse and dispersed teams, and they really need to share their data. They need to unify via that data, because the only thing that necessarily unifies perhaps a Badger data set and a civil engineering embankment design is the fact that they might be in the same place. So locational data gives you a common language that can be used, and it can be used to make decisions and get outputs, whether you're looking at a 2D, a 3D map, or some kind of dashboarded information system. You can customize the analysis to get more useful answers. So that might be something which tells you what kind of mitigation you should take if an ecological asset has moved within your construction site, or it might be something around site safety. Thirdly, you need to speed up data flow from field to use. So although you've got your site staff, you also have your in-office staff. Sometimes those are the same people, sometimes they're mixed, sometimes it varies, but frequently there is a data flow off-site and onto site again. That data flow, if you're using geospatial data, needs to be really fast, needs to be very clear when it's happened and when it hasn't happened, and it needs to reach the right people at the right time. So geospatial data, when done properly with your good data, your good systems, and your good communication, should answer these challenges. And I've got an example for you here where it has done. This article is actually taken from one of the magazines we publish every year within Atkins. This one taking a look at the work done for the East-West Rail Alliance, so East-West Rail 2, where they're at a construction phase. And of course, they've done their detailed design. They've done some amazing ecological analysis work at detailed design phase. And they've said exactly where the badger sets are and exactly what you need to do to avoid harming those badger sets. And won't you just know it, the badgers have moved. Turns out when an animal has legs or wings, it will move somewhere else. And of course, plants to the same extent, perhaps to a different degree. So how do you keep these badgers protected while also staying within your licensing legal requirements and keeping construction flowing? because of course when you stop construction, that's when the pound signs really start adding up. You've got heavy machinery, you've got people on site, you've got program delays which are potentially going to cost you money and fines if not met. So you don't want a 2-week delay because of a badger. What we did on this project was introduce some linkages within our spatial common data environment system, which allowed people on site to flag up the badgers in a really fast way, or indeed any other ecological asset. That data flowed centrally back into the office where our ecological clerk of work and their colleagues could see what was happening, immediately design some automation, design some mitigation through an automated process, and allow that to flow out back to site. Having that data flow sped up led to about 2,000 different interactions within this particular site. And hopefully you can still see my screen here, but I believe it has changed. And yes, we calculate around a 40k saving for the project thanks to this new system being in place. Really great use of geospatial for a construction site, a really obvious example of where a geospatial system has saved time, saved money, and achieved better results. So I'll hand back over to Thomas now for our next speaker.
Great. Well, thanks very much, Elspeth, for that. It's a really good sort of overview of the benefits of geospatial and how it's being used. And just one very quick question before we move on to our next speaker. Do you use little electronic tags on the badges so you know exactly where they are in real time?
I couldn't tell you the exact techniques that our ecologists use for different ecological assets, but obviously there's ones that you simply can't tag. But we do use a lot of different digital techniques now for the mapping of different species. So for example, we've got bat specialists out doing night surveys, and they could do that for really long, quite intensive and fairly stressful periods of data collection. We can now triangulate those audio signals to tell us exactly where the bat is, and therefore give you a much richer picture of the data of the actual bat behaviour. The same with things like newts, where previously we had a lot of people entering the water for, again, a relatively risky survey, something where a lot of risk had to be managed. We've now got a newt sniffing dog who is on the payroll, who is accompanied by an ecologist on a paddleboard. So that's fantastic, and it adds to the kind of eDNA type advances which are coming out, which make any kind of ecological data collection much quicker.
Right, brilliant. Great. Well, thanks very much, Elspeth. So going to move on to our third speaker now, who is Callum Agnew, a director from SOBEN. So over to you, Callum.
Great. Thank you very much. Yeah, so I'm going to talk about something a little bit different today to my other speakers. I'm going to talk a little bit more from the client side and how we can intelligently report our data and efficient ways to sort of present that in an easy to read manner. Quick introduction. I'm actually calling in from Singapore. I've been working in Asia now for nearly 10 years. I'm a qualified quantity surveyor and I've always had sort of keen interest in new ways of working, embracing technology. SOBEN, who I work for, we're a global construction consultancy. We provide project management, cost management, and other advisory services. We are a growing company with about 250 professionals across the globe, which includes across Europe, US, and APAC. And we're very much a tech-driven organization with a startup sort of mindset, which makes us a little bit different from our other competitors out there. We also work across multiple sectors, including infrastructure, rail, data centers, which I'm quite heavily involved in, as well as health and renewables. Okay, so I'm going to talk a little bit around the power of data and how we can present that. So as we heard from our last speakers, we are living in an era of data, especially in the project world where we have project data coming at us from all different directions. Especially when you're the client or you're working on the client side, it can be very difficult to get a clear picture of what's going on with your projects. especially if you have a program of projects right across the region or the world. Especially when different teams, different regions are all using different software solutions and platforms, become quite difficult to see what's going on, and information becomes quite siloed with little chance of sort of having valuable insight across your program. So by creating a more sort of common data environment across your program and introducing data visualization tools such as Power BI, Tableau, there's many different platforms out there, your data very quickly become very powerful. But of course, it's never that easy. You have to get the base right, ensure data information can be communicated effectively. So comparisons between projects then become far more straightforward, and then trends can be identified and informed to the client or owner. And experiences on one project can then be shared with future projects for continual lessons learned. Data gathering and visualization allows issues to be identified and tackled with speed and transparency. I think transparency is the key thing here. You can actually see where the issues are arising. For instance, if the dashboard flags up a cost overrun, being a quantity surveyor, that's something I definitely focus on. The project manager can immediately drill down to determine what items are involved and information to inform the decision of how to mitigate this event for this situation or further issues. That information can also be shared with other projects, other sister projects, which are happening at the same time, which can then mitigate future problems. Data analytic tools are also very powerful in working across multiple geographies with different industries using different ways of working. I especially find this working across APAC, where you have multiple different standard methods measurements, multiple language barriers. So having a automated system which allows for information or data to be translated into a common language is very important. I do have a quick case study just to sort of finish off my presentation of a client I'm currently working for across the APAC region. We were commissioned to help develop an intelligent project controls reporting function across the client's vast investment program. The main aim was to create a platform which allowed for automated and fast reporting right across their program. We developed a set of playbooks which created a standardized project understanding, which then used Power BI to report. So it was very important to have a standard suite of templates, a standard work breakdown structure. So every project was speaking the same language. Every project had the same understanding, and that then allowed for easy gathering, and everyone was talking the same language. The benefits that we found were we developed a common data environment which allowed for consistent work breakdown structure for easy data comparison between regions. So if the client had a new project coming up in say Taiwan, we could then reference another project in say Japan, and we could very easily pick up some trends of what's happening within those markets. We also provided a structure to the program of works to support procurement, sourcing long lead equipment, sourcing other items, especially in the current market we're facing ourselves in at the moment, where long lead items have to be sort of managed early. So having that that information broken down into that manner really allowed for those fast decisions to be made. We're also able to use the project data to inform the client on the health and progress of their investment. This really provided an up-to-date information on project performance, risk, successes, and decisions to be made. This is really the crux of the dashboard. It really helped provide improvement to communication to the investment committee. It allowed this in turn allowed for fast decisions to be made, which allowed for the program to run a lot more efficiently. Finally, it's also looking at a structure for data collection and lessons learnt in historical data. This sort of 360 learning process will provide benchmark data for future projects, and that continual learning as the program eventually grows. That's my presentation. So I'll hand it back to Thomas now.
Great, thanks very much, Callum. Just a quick question before we move on. So it's interesting that you're actually working in different countries using these tools. I mean, I don't know, correct me if I'm wrong, but if you were using third-party data, and some of the other presenters have talked about sort of using publicly available geospatial data. I mean, are there issues for standards? I mean, are different countries using different sort of standards, and you have an issue getting the kind of combining these on one platform, or is that not an issue?
There is that's the biggest issue, is having that sort of centralized database of information. So there is a lot of sort of automation API things you can develop to pull from one platform to another platform. But that's really where the work is. The work is creating those API functions to sort of bring it into a central database and then report it. Especially in a sort of cloud environment where you do have some security issues, which you sometimes have to ask nicely to the certain vendors if you get access to that. But it is one hurdle which you do need to overcome and understand what. That's really step one: understanding what your client is using, what are your sort of consultants using, and then coming up with that sort of understanding of how we can collaborate.
Great, well, thank you very much, Callum. So we're going to got one more speaker now, Christina Rui Nolasco, who is Senior Digital Construction Manager at Sir Robert McAlpine. And Christina's going to talk about Cloud Point Survey. So over to you, Christina.
Okay, thank you. Can you see my screen now?
Yeah, perfect.
Okay. Yeah, perfect, okay. So yes, I'm Christina Rui Nolasco. I work for McAlpine and the special projects. This is a section, McAlpine is a main contractor, and where I work is a section that specializes on heritage buildings. So it's a bit of a niche that we have here with the heritage BIM. What I will focus the presentation today is what we do around the site capture and point clouds, geolocating the buildings. So for us, because these buildings are existing, laser scanning it's vital for us. And yes, and really surveying is very important for these projects. So we tend to do three points of recording the site and recording information. And this is before the work commences on site, after demolition and substrip, and upon project completion. And this will vary between different degrees of point clouds, depending with different degrees of accuracy, high resolution images, and photogrammetry as well. So an example of how what the reasons why we find this critical for us is when we start on a project, and this is you know, having models or not having models, it doesn't really matter. We would have to do a survey, provides us with the correct real world coordinates, right? So that we can provide this information to the wider team to progress the construction on site. Many times we realize that these coordinates that the project has been using until that point are not exactly right. So it's key that we set this from the outset of the project. So we can then inform the setting out of the grid lines. It's going to be quality assurance for us. It's going to have a historic record that the team can use during the construction to go back and forth. Because in some cases, on the buildings that we work, we don't have ownership of the entire site, and we have to we have to have that database of the entire scheme. After demolition and substrip, it's very important to produce another point cloud where we are geolocating all the objects, all the items of the fabric of the building in relation with each other. This is where the setting out of the grid lines will be more important, and we need this accuracy from the point clouds. It will be validating the design that has been based a lot on assumptions on these buildings, because obviously it's an existing structure. We are going to help with the discovery phase with this, and it will be a database for elements that might not be modeled or represented on drawings, right? So we have projects that would have beam requirements, and we provide models, or some others that don't. So in any case, this provides a database that it's invaluable for the project to move forward. A few examples of how we use the point cloud. So on projects that we don't have models, we can use this 3D, this point cloud as a baseline for the subcontractors to produce the model and coordinate the design moving forward around the existing services that might not necessarily be removed. We also have design validation. So where after doing the subscript, as I was explaining, you might find that where there was an assumption that there was one column, there's actually two, the sizes are not correct. So all of these will help us develop the design and move forward on construction, at the right time. We have then the next step would be the project capture. We use Dialogs as a tool on most of our projects. With this tool, because we have done the work behind with the point clouds and locating the building correctly, we can then use 360 cameras on site to and the GPS on these cameras to position the images, and then compare different through the construction process different moments of this. Also comparing it to the model to understand if it's following the design, the construction on site. Oh, well, something else, sorry, before I move on. On Dialogs as well, we are trialing a new feature that it has with 360 cameras. You can record a video and it will also, using the GPS, locate the video on the floor plan for the site team to view. Then we have a project completion. We want to also cover the building of how we're handing this over to the client and have that record for us. This we use, depending on the needs of the project, we will use cameras that will geolocate the images, or some others that won't, but that will be really depending on the project. And finally, a bit of challenges and opportunities. So challenges is the setting out of grid lines. It's important that everyone agrees on the accuracy and the ambiguity of the information. It's going to be very important, the point clouds, to incorporate the findings to the design. The size of the files when you're working with point clouds, it's very important. So it's something that needs to be looked at from the start of the project, and the software and hardware capabilities. So selecting the right solution for each instance, it's very important. And then opportunities, well, it's common data source. There's not going to be ambiguity because everyone can agree that the scan has been produced with enough accuracy for the project. It's important to have early engagement with the design team, and obviously the design validation that is vital for us. And that was just the presentation that I was going to show. So back to Thomas now.
Great, thank you very much, Christina, for that. That concludes our formal presentations now. So if I can invite all our panelists to put on their cameras and microphones, we can now move into, we've got about 15 minutes left. We can now sort of discuss some of the issues raised. Now, I'd like to encourage our audience, if you've got any questions that you'd like to put to our audience, now is the time to do so. So just to kick off with, I guess Maria touched on this actually, is really the issue around the availability of this sort of geospatial data. I mean, I saw Maria using it from a whole range of different sources. And obviously there's probably gaps. I think you said that there were areas where we didn't have data available. So, I mean, the government's Geospatial Commission has an ambition to create a coherent national location data framework. And actually, with parts of that, improve access to better location data. I guess, with all of you, with your experience, is that really going to help? And is it? I mean, is a lot of the data there available already, or is there a huge amount of work to be done to sort of create this coherent national location data framework? Anyone care to kick off?
If
Maybe Maria?
I can kick off on this. Indeed, we always explore when we want to work in any project, we always look on what is available out there, first of all. So this is the first thing we do. Definitely, if we have more data available, that would be a great tool that we would have, like great set of information that we would have from the beginning of our design work. And actually, if that is made like in a consistent way, well, I guess that the government could set up a consistent way, and definitely they should monitor these data sets and eventually create probably a methodology to update those data sets regularly, or whatever it considered to be like a good frequency for updating those data sets. That should be great information to have, because then, as I mentioned, like we can explore like the areas of our interest, we can understand the challenges that we will face, and if we need a more detailed survey to be done, then we can focus which are the areas that we really need to have something more detailed in terms of information. So for example, I mentioned like the roads or the rails. Yes, we have like long, too many kilometers of roads that we need to design, but do we really need to design in the same level of detail all the length of the road? Probably not, because some areas, they are straightforward, but we can focus where we need to allocate more budget probably, or we need to allocate more resources to resolve some issues. So definitely that would be a great set of information to have in advance.
Great, thank you. And Elspeth, I mean, I guess this could benefit you too.
Yeah, absolutely. We are involved with a couple of projects at the moment which are looking to streamline this more joined up data delivery. So one of the largest Geospatial Commission activities at the moment in the UK is NUAR, the National Underground Asset Register, and Atkins is informing on the spatial side of that development. The idea that you can have utility information from every utility owner or manager within the UK in one database, and available, updated, change managed for everyone to then use on their projects. That could be really transformational, considering often the length of time it takes to source utility data, the limitations that are inherent within that data, understanding whether it's good, when it was collected, what the accuracy level is. And that kind of consistent methodology and data standard being applied across the board could prevent any tragedies from occurring from poor data updates, such as we saw with the Scottish Rail incident. I think it was last year or the year before, perhaps, where at fault was BIM data that hadn't been updated correctly.
Right, no, it really, I mean, that sounds incredibly significant. And I guess from a more prosaic level, all the people digging up roads, probably unnecessarily, might stop as well. I mean, Christina and Callum, do you have a view on this?
For us, having this information from the start of the project would be vital. Yes, just that to push projects on construction phase, you need to have this information. So yeah, I would agree.
Okay. I mean, I'm trying to get a sense of where the construction industry is in terms of using geospatial data, in projects. I mean, we've been talking about BIM for years, haven't we? And you get the, all the sort of major firms in construction are kind of using this. It's every day. Are we in that same place with geospatial, or are we at a much earlier stage in its adoption? Anyone care to comment?
I would imagine it's earlier stages. From my understanding, yes.
Right.
Sure.
Yeah. And are you?
So,
I mean, sorry, Maria.
Okay, so I believe that in the construction there are lots of opportunities to use geolocated data. I believe we are not there yet. I believe it's quite soon. And I think Elspeth mentioned some of the constraints that we have, that you might be like in a remote area that you don't have really good connection. So the live use of data probably is not that advanced, but having geospatial information available definitely it helps also in the construction phase. As a team, we have worked a lot in the design process, but that doesn't mean that we don't consider or we don't think what will happen at the construction phase. It's just that we believe that it's super important to approach the whole design and construction phase as an holistic way, because you can resolve issues from the very beginning. So maybe when we talk about construction, we consider, okay, what is the live information that we have available, how I can send the feedback to my team, or how I can update quickly a data set and see which are the issues. That maybe in some cases we have some limitations in terms of technology and a good connection in some areas, but in general, I believe we have already so much information that if we inform all the stages from design to completion, eventually if we have a look at operations later on, we can resolve so many issues.
Right, I see. Yeah, so really in a way, you know, it's great having all this work being done on sort of creating this national location data framework, but they kind of need to upgrade, and I don't know if it's 5G or other technologies, it needs to go hand in hand so you can actually leverage that data effectively, particularly in construction where you might be somewhere remote. I guess, I mean, I think you touched on this, Elspeth. I mean, another issue is skills, isn't it? I mean, I think, you know, there's been a lot of talk about upskilling the industry when it comes to BIM. Are the skills available when it comes to integrating geospatial sort of knowledge and skills? Are we up there? Do we have lots of professionals out there who are kind of very familiar with this, or is there a big training, upskilling piece needed?
I think there's definitely quite a bit of upskilling needed. Frequently you'll see civil engineers who are really well versed in CAD and CAD technologies, and they are BIM natives, but they don't necessarily understand some of the complexities you get with spatial data, some of the geometry errors, some of the coordinate system hijinks that can come in when you look at a GIS system as opposed to a CAD system. So knowing the differences, knowing how to convert, knowing how to work and use the correct vocabulary when you're looking at those two different but very much related pieces of data infrastructure, that's really important. And also when you're looking at site personnel outside of the kind of design framework, then I think GIS skills do tend to be quite low, and an upskilling there would have huge advances for the industry.
I mean, you know, if you look at site personnel, I mean, where are the gaps? I mean, is it collection of data, or is it sort of using the data that comes through, you know, in CAD or something like that? Where does the gap sort of sit?
There definitely are issues around capture of data. So which data gets collected, what metadata is being collected with it. So if, for example, you say that there's a badger set here, have you recorded the time of day when it was collected, when it was active? Is the badger set active, or is it disused? Is it a main set location? And having that data in a way that is machine readable. So it's not just kind of a flow of consciousness type answer. It's a text from a list that will allow your GIS system to read it, categorize it, analyze it. That's really important, and obviously applies to many things apart from badgers, which I think this call has gotten quite fixated on in a good way.
And I mean, a second part of this equation is the technology. I mean, do we need bigger computers? I mean, again, you touched on yourselves, didn't you? But is the equipment that people have on site good enough to sort of take advantage of all these new benefits?
That is a struggle for us. Selecting the right software and the hardware, and it's key. And yeah, these data sources are the sizes of them sometimes is humongous, and being able to transform the data and analyze it and extract the insights from it, you need powerful machines, or you need this data to be converted before the site team can actually utilize it, right? So yeah, this is a key item.
Right, I see. And is that a barrier, do you think, really, to wider adoption of these technologies?
Sometimes, for us,
Yeah.
sometimes yes. Yeah.
On the other hand, I would say the good thing that we have right now is the cloud infrastructure, which can leverage a lot
Yes.
this work. So in the work that we developed for London Underground and where we received as an input the point cloud, I understand that probably, well, Christina should know well that what is it, how difficult it is to work with point clouds. But the fact that we have a cloud infrastructure and we can work on the cloud, it means that if we create methodologies and processes to push the information on the cloud, then with simple hardware such as our mobile phone or any tablet, for example, that it has, it can use the geolocation, geospatial information, then we could create applications and we create methodologies that we can track different issues when we are on site. So I believe that there are different gaps, I would say, from many different aspects. Yes, we are missing data. We are missing the right technologies or the right tools yet. We are missing the right capabilities. But on the other hand, we are in a great position that technology has advanced so much and it is available out there. So it is up to us to embrace these new technologies and try to take advantage of those.
Right. And someone's actually got a question coming in to asking the use of drones useful in this. You know, you've got particularly, I mean, big infrastructure projects and, you know, or sites. I mean, can you, Christina, sites in a very congested location? Yes. Could drones be useful?
Yes, for us, we have a geospatial team within McAlpine, and they have a drone that we utilize for certain projects, especially for capturing facades and and areas that are difficult to access. So yes, having that information from the drones, it's very important as well. Yeah, for us. Right. And I imagine that for infrastructure is even more interesting. Yeah.
And can they capture sort of, you know, location data when they're doing a survey, and feed that back into a sort of BIM model?
That's it. So we would obtain sort of a point cloud of the facade, right, and it would be geolocated and with all the accuracy that is needed. So yeah, 100%. So
right.
From my perspective, drones are great at collecting additional data metrics as well, but really quickly. So once you've got your point cloud, perhaps you add in a thermal imaging capability in your drone, which our drone pilots use to assess buildings, including on live construction sites. And having that thermal imagery, you can rerun your drone site every 2 weeks if you wanted to see what changes both in your point cloud and in these other vectors. Perhaps biodiversity net gain or something gets thrown in there as an automated analysis.
Thank you. We're nearly out of time. I've got one last question I'm going to throw at you, which I think is pretty important actually, which is really the benefits of geospatial data during the operational asset management phase of projects. And I know one or two of you have touched on this, but is this the really big gain? And then that doesn't have to be on an infrastructure project; it could be on the building level, knowing where a valve is in a big office building. Is that where the kind of the benefits really lie long term, or not? Maybe.
From a project level, if you have clients with various infrastructure, various buildings, this is important for them, so they can use that information geolocated, and especially for when you're talking about linking the O&M information to the assets from the model or for the point cloud, whatever. And when they use that information in the CAFM systems, it's very valuable, I believe, for our clients.
Maria?
I think it comes back to, oh, sorry, I'll let Maria go.
Go ahead.
Oh, yeah. Thank you. I feel it comes back to that old adage about not being able to manage what you can't measure. And again, with the geospatial mapping, any kind of locational link makes it very easy to manage lots of diverse assets within one frame, whether that's in your headspace or within a dashboard. So having that at the operational stage in GIS format, the data is invaluable for management.
Thank you. So Maria, did you want to come in at all?
Yes, again, like I would like to mention again that what I said that previously, that I believe we shouldn't look only at the operational stage. Everything is interconnected. Like from the time that we think and we have a concept for a specific design, that would affect eventually how our product and how our design, whether this is infrastructure project or building or anything that we design, would operate later on. And I would say that if also like the government could create a strategy not to just capture point clouds from the environment, but how we can separate the information from these point clouds. So which are the buildings, which are the trees, what is the equipment that we have underground, so all the pipes that we have, all the cables that we have. So if we can have a way to track this information, then definitely it helps later on to maintain our cities, to maintain our infrastructure, and keep track on how our built environment operates.
Right, great. Well, thank you very much. I think that's a really good note on which to end on, actually. It's kind of, it shows you know, the huge benefits, but also the scale of the challenge in getting to that point. So I'd like to thank all our speakers for today. It's been a really interesting session, and also to our audience for listening. If you want to see this webinar again, you can download it later, and there will be a short survey appearing on your screens after the webinar finishes. So I'll be grateful if you could just take a couple of minutes to fill that in. So thanks everybody, and hopefully see you all again.
Thank you.
Thank you.